In this video, we're going to go over some examples from 10.5. So if we look at the book, we're looking about the difference between two population proportions for large independent samples. So some things that we're going to have to kind of highlight here. The sampling distributions, P1 and P2, is going to be approximately normal with its mean standard deviation is given as P1 minus P2 here. So the standard deviation is going to be calculated by taking P1 times Q1 over N1 plus P2 times Q2 over N2. And then of course Q1 and Q2 are respectively calculated by taking 1 minus P1 or 1 minus P2. The error and the confidence interval, so we're going to have to calculate the z-value based on the normal distribution depending on what confidence interval that's given. We'll give this corresponding z, and then we'll have variety of different things to calculate depending on if they want the sample size or what they're going for there. So let's look at number 5. We're looking at these two different airlines, and we're given that the confidence level is 90% confidence level. So we're going to have to calculate our z-value from the normal distribution table. So the 90% confidence level, going to the standard normal distribution curve, looking for the z-value, that would give a 90% confidence level, would be the area to the left would be 0.95. So the area to the left, 0.95, is z is 1.65. So z would equal 1.65. The margin of error is given as 0.03, and if we go back to the book here, the margin, this would end up being, actually it's on here, this is going to end up being the margin of error, z times the kind of this standard deviation of the difference of P1 and P2. So going back here, getting that formula, P1 hat plus P2 hat plus or minus z times, in this case, the standard deviation of P1 hat minus P2 hat. This is what you're trying to calculate. This is the error, the margin of error, and it's estimated at 0.03. So I'm given z, or I've calculated z for a 90% confidence level, so z would be 1.65 times, when I'm trying to solve here, is going to equal 0.03. So going from the book, the formula for this is given here. So P hat 1 minus P hat 2 is 0.03 divided by 1.65, and it's also the square root of P1 times Q1 over N1 plus P2 times Q2 over N2. We're calculating the N that I need to, the number of samples I need with a P1 and P2 of 0.5. So one step further here, I have 0.03 divided by 1.65 equals the square root of 0.25 over n plus 0.25 over n, which ends up being the square root of 0.5 over n. So now I need to solve for n. So rearranging the algebra here, I calculate 0.03 divided by 1.65 equals the square root of 0.5 over n. If I square both sides, I get rid of the square root. And then if I multiply both sides by n, and then divide by 0.003305, I get approximately 1,512.5, and then of course rounding that up gives me my n value.